Emmanuel here. Welcome again to another class. Now, in one of the previous classes, someone mentioned something about the integration constant, and they wanted to know the reason why we always include the constant whenever we integrate a function. So, we're going to attempt to answer his question. So, this class will be a bit of an explainer around the integration constant, and in doing that, we're going to assume that you not know anything about integration, and so the class is going to be very basic. So, every one of us already know that integration that if you want to integrate a function, you simply increase the index of the function by one, and then you divide by the new index. Then you leave the coefficient the way it is. Then you can add an arbitrary constant. For example, you want to integrate this function, say f of x equal to x raised to the power n. Now, to integrate this function, you simply increase the index of this function by one. Then we divide by this new index. Now, whatever coefficient you have here, which in this case is 1, you leave it the way it is, except you want to simplify with the denominator. Then you add the arbitrary constant. So for all intents and purposes, these are the steps you take if you want to integrate a simple function. But every one of us also know that integration is the reverse process of differentiation. So while you integrate a function to obtain the derivative of while you differentiate a function to obtain the derivative of the function, you integrate that derivative to obtain the original function from which the derivative is obtained. For example, you have this function. To obtain the derivative of this function, you have d 2x cubed minus 7 dx. And now remember the formula for differentiation. You have an x raised to the power n minus 1, where a is the coefficient, which in this case is 2, n is the exponent or the index, which in this case is 3, and then of course you have the exponent minus 1. So apply this formula here. You have the coefficient multiplied by the exponent x raised to the power the exponent minus 1. That's where integrating term by term. So we are differentiating term by term. So we have differentiated this. So to differentiate a constant, now remember that the differentiating a constant gives you 0. So we have 0 here. So we have this off. So simplifying now, we have 2 times 3 is 6. X raised to the power 3 minus 1 is 2. So 6x squared is the derivative of this function. Now, if you want to get back this function, we integrate this. So integrating this function, we have the integral of 6x squared dx, and this will give us, of course, if we use this formula, we have 6x, of course, increase the index by 1, increase 2 by 1, that is 3, then divide by 3. Then time to add our constant. Now remember, from the original function, you can see that the constant here is minus 7. So add minus 7. Now simplifying, we have 2. So this becomes 2x cubed. Now plus minus is minus. So we have obtained this function again. So this is the integral of this derivative. Now this is the derivative of this function. I've come full cycle. Now remember once again that the reason why we have this minus 7 here is because we know from the original function that the constant here is minus 7. Otherwise, we would have put c. Now, let's assume we have another function, like let's say y is equal to, say, 2x cubed. Now, this time around, we're not going to put any constant. So, a constant here is 0. Now, to obtain the derivative of this function, we'll have d 2x cubed dx, and this gives us, of course, we go by this formula, we have 2 times 3x 3 minus 1. Now there's no constant to differentiate, and so this gives us 2 times 3 is 6x, 3 minus 1 is 2. So this again is the derivative of this function. Now we want to get back this function. We integrate this. We have the integral of 6x squared dx. If we integrate this, we go by this, we have 6x cubed over 3 plus. Now time to add our constant. Now you can see from the original function that there is no constant there. There is no constant to add. So we have nothing to add here. So we have 2. So simplify, we have 2x cubed as our final answer, which is this. So we have also integrated this and we've gotten the original function. So we can see that from these two examples that we just did, this one and this, you can see that while these two functions are completely different, evidently, you can see that their derivatives are identical. And this is because during differentiation, whatever trace of any constant in the original function gets lost. And this presents a kind of dilemma to the mathematician, because remember again that integration is the reverse process of differentiation. So when we integrate a function, the assumption is that we're actually integrating the derivative of another function whose history and the original construct we do not know. So now, unlike in this function where you know the constant, so you have the history of this function. So when you are integrating this derivative, you know what constant to add. You know that more often than not, the kind of integration problems we encounter on integration journey does not provide us with any further information about the original function. So to avoid any problem, we simply add a c. We simply add a c in recognition of whatever function, whatever constant that may have been in the original function that we do not know about. Now this constant is of an arbitrary value. This value will be determined if we have any further information about the original function. Like in this case, we have the information about this, so we can now add it to this. And when we have this kind of function, or this kind of integral, we call it an indefinite integral because we don't know the value of c. But when we know the value of c, once again, like in this case, we can call it a definite integral. So if you know the value of c, or you have information that can lead you to the value of the constant that you have in the original function, then that will be a definite integral. So this is the reason, and this is the explanation I have. I hope the explanation has been clear enough. But if you have any further question, you can put it down in the comment section and we look at it, and if it has any merit, we'll maybe do another video to explain further. So here you have it. Until next time, keep solving problems, not run away from them. Bye bye.